In this lesson, we shall evaluate this integral here of a nested radical, and we solve this particular definite integral in a step-by-step manner as follows. Right, we still have with us the integral of the nested radical, and it is a definite integral with clear limits of integration. Now, certain things, therefore, remain very, very evident. It is the fact that we actually are dealing with what we call a nested. We're dealing with what we call a nested radical. And that is what we are trying to integrate. And so to integrate these step by step, we actually take note of a couple of things. First, as usual, but as always in mathematics, we actually copy down the question. Copy down the question like so. We copy down the question like this, and then we let y be the nested radical, x plus the square root of x plus the square root of x plus the square root of x. And upon careful observation, we are able to observe, therefore, that this is actually y equal to the square root of x plus, and then the square root of the x plus, that becomes a y. We square both sides. We square both sides exactly in this particular manner, and we can divide the green board. And so we get from this y squared equals x plus y. And we transpose the terms like so. And this is what we obtain. And we therefore have y squared minus y minus x equals 0. And if you look at this very carefully, we can be able to solve for y out of this equation. Y squared minus y minus x equals 0. We know the quadratic, y equals minus b plus or minus the square root of the b squared minus 4ac all divided by 2a, which is 1 plus or minus the square root, which is minus 4ac divided by 2a. So this becomes 1 plus 4x all divided by 2. Right, and we note that indeed from this particular observation that our y is the nested radical, and the nested radical is greater or equal to 0, but also we require that our x as well is greater or equal to 0. So our y is greater or equal to 0 together with x greater or equal to 0. Exactly that way. And so what do we then observe out of this? We're able to make a couple of further observations. All right, so this means that y equals 1 plus the square root of 1 plus 4x all divided by 2 only. And the fact, therefore, that 1 minus the square root of 1 plus 4x is invalid. Invalid. Why? Because for any x, for an x that is bigger than 0, the square root is going to be always bigger than 1. So we have that. So now, as a consequence, we have the following there. So it means that, therefore, we have the following. So you can say, hence, the integral from 0 to 2 of the nested radical, like so, with 4 x's quite that are visible under the radical sign of this. And so this is the integral from 0 to 2. Right, so when you look very carefully, we called this y, and so it is 1 plus the square root of 1 plus 4x, or divided by 2 with respect to x. Exactly this way. And so if you analyze that, but very carefully, we make the following observation: 0 to 2. We have 1/2 1 plus 4x dx. And so this we can write as the integral. We have dx. We have 1/2 of the integral from 0 to 2 of the radical of 1 plus 4x dx. And so we continue with our evaluation. So we're going to integrate this one first from 0 to 2 plus 1/2 the integral from 0 to 2 of the radical of 1 plus 4x with respect to x. Exactly this way. And upon careful evaluation, or rather, observation, we've just got that we have 1/2 here from 0 to 2, and then with 1/2 the integral from 0 to 2 of the square root of 1 plus 4x dx. And so we're going to let the following. Let me just write below here. So we're going to let u be 1 plus 4x for this part. And this means du is 4 dx. Meaning, therefore, dx is 1/4 of du. Right, so that allows us to actually perform the integration, but more so, we can draw a little cross like this with x's and corresponding y values. X is from 0 to 2. If u is 1 plus 4x, in the place of x, you put 0, which is 1 plus 4 by 0, giving us 1. Whenever x is 2, we have 1 plus 4 by 2 equals 9. So we continue as follows. Right, so we actually, from this, able to have, we still have 1/2 from 0 to 2, 1 to 9, and then you're going to have the square root, because whatever we have under the radical, the 1 plus 4x is u, and the dx is 1/4 of du. Exactly in this fashion. So we still keep this one here. We still can keep. Of course, we can, simplify that. But if you multiply 1/2 and 1/4, we get 1/8 of the integral. And you have exactly this here. We have 1/2 of 2 minus 0. And so we have 1/8 of this one, which is 2/3. And then we have u to the power 3 out of 2 from 1 to 9. So we have the following. So in this case, we're going to have 2 divides 8, going 4 times into 8, and therefore this is 4 by 3, 12. So this is going to be 1 divided by 12. 1 divided by 12, u to the power 3 out of 2. 1 to the 9th. Multiply this one by 1, which is 9. 3 out of 2 minus that, 1/12. And therefore 9 is 3 squared, or 3 by 3, being raised to 3 out of 2. And this is 1 plus 1/12. The 2 cancels, giving us 3 out of 3. And therefore this is 27 minus 1. And that gives us exactly 26 there. And so you can simplify this because 2 goes 13 times and 2 goes 6 times. Right, and so this gives us 6 plus 13 out of 6, which is exactly 19 divided by 6. Just exactly 19 divided by 6. And henceforth, right, whenever we have the integral from 0 to 2 of the nested radical of x plus the radical of x plus the radical of x plus the radical of x. Yeah, so this one here is exactly what we saw. It is exactly 19 divided by 6. It's exactly 19 divided by 6. And so, and this here is the final answer to this particular question of the nested radical. And we have solved this particular question step by step. And thank you for lending us your attention. Until next time, take care and goodbye to you.